when I looked at the C2 compiler, I felt like there is not room to do this because you would have to need to compile time evaluate everything. Going through that revolution where you have to all these new things coming that were like massive speed bumps and massive new ways of doing things. I hate dependencies. So I think this is just making me giving me anxiety attacks just thinking about these layers upon layers, and then it doesn't work, and you can spend like weeks just trying to get something to work that is, in the first place, almost doing nothing. But it has done something somewhere for someone. That's why what's there, and everything should work. And if it's not working, then QA can go to like, look, you added a bug. That should be like the relationship. So just go out and have fun programming, everyone.
Hey, what's going on, folks? It's Mike here, and welcome to an exciting conversation with Christoffer Lerno, the creator of the C3 programming language. Now, the C3 programming language is an evolution on the C programming language, and it really has some exciting features. So we're going to dive into those and look at the C3 programming language with the creator, Christoffer himself. But we're also going to talk about his origin story and get some of his wisdom about software engineering throughout this conversation. So sit back, relax, and enjoy this conversation with Christoffer Lerno, the creator of the C3 programming language. Christoffer Lerno with me today, who is the creator of the C3 programming language. And I want to just thank Christoffer now already, and I'll thank you many times for taking the time to be with us. So it's very excited. Thanks for being here today, Christoffer.
Thanks. It's going to be fun to talk with you about like C3 and any other topic that might come up.
Yeah,
So.
Now I have to ask you, the last week or 2 weeks, I'd say, has been a pretty crazy time for the C3. You've been getting a lot of attention from other YouTubers and so on. So how has your life changed in the last 2 weeks? Has it been pretty busy talking about C3?
Yeah, it came kind of sudden that Soding did this stream about C3, and then he did another one and the third one. So suddenly, like a lot of people showed up in Discord asking all sorts of questions, and I was just used to the normal kind of, normal flow of maybe having one or two persons coming in and new persons coming in a day, and now suddenly it was like 30 or something, and just everything exploded. So I had to put some work stuff on hold to kind of just get, be able to talk to them and like just answer the first 100 questions, and basically just welcome them, right? And when you start a new language that is unknown, there are not many people to ask. There were some people already that had been using C3, but I can't really ask them to kind of explain every detail for everyone, like take their time. It's like, it's my language, so I have to take that time. But it's also fun, and this is super interesting to kind of see what they want to do with the features, and like what they are thinking that the features are like the ones that are added to C, because C3 is actually, is C plus plus some features. And like if they just go into the programming with a kind of C mindset, that's going to work. But then when they try to experiment with the new features, that's where people get kind of confused, because there are standard ways of doing things, like for example, generics, right? We have like C++ style, and that kind of style is the common one, and C3 doesn't have that. That's generic modules. So when people try to do that, they need some kind of maybe some explanations how do you do that. And another thing that kind of is a problem in the beginning would be like memory management, because though you have like the C memory management, the standard library has in C3 has a temporary allocator, and that was very nice to use because you don't have to think about allocations. It's like stack based. And to teach people how to use that properly, or people who's even maybe they didn't even use C before, and then they're completely, unprepared to kind of work with memory, or they have like, oh, it's going to be like maybe some other language like C++ or something that has like managed memory, and they think like maybe it's supposed to be like that. And I mean, they have no preconceptions, so it's interesting to see what they assume. But I also want to be there and like explain, like you can do it in this way, or like simplify it in this way. So that's super fun, actually.
Yeah, that makes a lot of sense, and I'm sure it's informing how you're developing resources and sort of the references and examples. Um, and we'll get into this a little bit more in a few moments, but I think it's interesting, these new systems languages like C3 that have different types of memory styles, and that's part of the appeal. But as you said, it's something new that folks have to learn. They're not learning it in school usually, for instance, or if they're coming from a different background of, say, just pure C or Java or C++, that is going to be very new. So it's very curious. But before we get into C3, I do like to, take a step back sometimes with developers and language creators and kind of figure out your origin story and what kind of leads you to C3.
Yeah.
So I'm going to take you, on the way back machine, so to speak,
All right.
uh, and ask you, do you remember what the first program was that you created? What language was it? What type of programs were you writing?
That was when I was as 9 years old. This was back in the 80s. So I was, this should be in 82 or so, right? And then everything like the home computers, home computers just arrived around this like time, at least for like the average consumer. Suddenly you could buy them. And I wanted to learn programming because I thought that was I loved science fiction when I was a kid, like robots and stuff like that. And computers were like the closest to science fiction that you could get. It's like in the movies, and it's already here. So I wanted to learn programming. So it was probably something like these most simple, basic programs where you kind of ask your name and then say hello. Like input a dollar, like what's your name, and like input a dollar, and then you just print that hello. And yeah, that's probably the first program. I don't remember it, but that's what you did, right? And then you started to do like a little more complicated with like maybe some goto, and that was basic. Basic was, you know, uh, pretty straightforward. Um, but you but and well, let me just this fun thing was all the computers at the time had basic or variants of it, so you could kind of, if you learned basic, you could write programs from all machines that were available, and you just had to learn the specific params of basic. There were like some computers had really good basic, like the CX Spectrum. That one had the great basic, and like I think the C64 had a terrible basic, but it had great music and the sprites that were great. So it kind of uh, outweighed things when you started to do things that went beyond basic. But
So,
yeah,
so
basic. That was like my childhood.
yeah. So were you teaching yourself basic at this time from programming manuals, or just kind of messing around on the machine, or did you have some of the basic through schooling at the time?
I had this, I think, like 2 semesters, so where it's like some course you can take, like for just in Sweden there were like different um, these organizations that kind of had classes that for adults, but also some for children, and they, introduced this like a bit of programming. It was all very new at the time, and that particular computer that I was using was kind of expensive. So I eventually, I was attending these classes, but I didn't have a computer, and I nagged my mother about it, and finally I got a computer. And the problem was that was like this Atari 600 XL, and it had great graphics, but it didn't have, it was had super expensive games, and so I wanted to program my own games, like have something to play. And at the time there was like these amazing magazines, these computer magazines where you could like have was chock full of listings of different games that you could type in, and from really advanced to very simple ones. So I basically learned from that, typing in these things, and most of them were not for the Atari. So I learned the Spectrum basic because that was kind of easy to figure out. So I would port things from the Spectrum and try to get that to work. And that's kind of, you would type in programs, you would try to convert them and stuff like that, and play around with ideas. Like the first time I saw this, how to do an adventure game. Okay, so an adventure game just have like these verbs and stuff like that, and you could put them in an array. And as a kid back then, so like always, it was very new, and unfortunately, uh, the listing depended on um, having arrays of strings.
Mm-hmm.
Okay, but the Atari Basic didn't have arrays of strings.
Mm.
So I could just like I figured out that I could, have an index of where each word started, and big, big string.
Mm.
Like so you could get like the index, like what you would do in a summer or something like that if you didn't, yeah. But I figured out, and it's like started writing, and I was like, oh, it's getting done, and I ran out of memory. Because these
Oh
machines are like,
no.
I don't if it had 32K, I don't think it had me like it was 16 or something. I ran out of memory because I did these strings, and it was like, no, I can't write my game here. So that was nice when I get like later I bought a Spectrum so I could write more adventure games, which I wanted to write. So yeah, those were the days really. It was super, I think it was super easy to get started with programming in those days. Because just you open your computer, and if you wanted to do something, you either had a program that you loaded, and you had to have patience, because it was
Mhm.
tapes. You started that program, went out 30 minutes, came back, and now your friend and you play this game, and it was getting kind of boring because no game could be like, all those games were kind of very hard but fun to play in the beginning, but you could play about like 20 minutes before you got bored. So now you had to load the next game with like additional 30 minutes. And so you didn't get like this experience of sitting, for a long, long time, unless you were programming. So yeah, it was those were different times really.
Yeah.
And then you had to have this super patience though if you when you type in some longer game, because those were, you know, 2000 lines, and basic. It was as some of these, to save memory in the C64 basic, you you could omit the spaces. So some of
Mm.
these rows were really hard like a lot of that was really hard to read. And you kept typing in, and the worst thing was like the ASM parts, because those were like just a lot of numbers, and you have to get everyone right. And you remember saving everything. If you didn't save it and turn off the computer, it's gone. And I didn't have a tape recorder to begin with, so I like had to retype my programs every time.
Oh no.
I want to play this game. Like, yeah, let's just type it for 2 hours. Like, that's when you can play the game.
So I mean, there's a few lessons, and this is funny because I get similar lessons when I ask other folks about their origin stories. I think the first one is to appreciate how good we have it today, to be able to save our programs, at a minimum, for sure. But there's sort of something interesting there where you said you were looking at other languages already to kind of port, and I think that's a really interesting learning exercise. Um, because you were almost looking at some of the other basic programs and having to think in another language. And I wonder, do you think that really helped you learn early on? Because you're effectively just spending a lot of time reading code, which I think is really important for learning, then having to understand it before translating it. Where I see a lot of programmers just dive in and start typing code. I think that's kind of an interesting learning experience. Do you think that helped you in any sort of way?
I don't know, but I do enjoy reading code. So maybe, I mean, that's be one of my strong points of being able to like sit down, actually look at the code and read it. And I like to read code. So maybe. I mean, I haven't thought about it, but maybe. As you kind of got though, you from that time, you kind of got instincts about programming though, kind of internalized a lot of things because I didn't. Well, maybe I jump ahead here, but I didn't intend to be a programmer. That was not my intention. So at the university, I studied engineering physics. Was thinking into theoretical physics, and um, and then I just there just had been some computer courses in C++ and Pascal, and that was just like it was just another language you can pick up and start reading, writing in. Uh, and then I started working as a programmer just to get some working experience, and it turns out that like I already had like surprisingly good instincts about that and could see like my coworkers' code was pretty bad, pretty bad, and I could improve it. It's like I've never worked as programmer before. I like almost only read my own code and a bit of some libraries that I use, and then jump into professional programming, and suddenly you see like, oh wait, I have to clean the code because it's somewhat of a mess. And maybe despite like being mostly basic that I had for a long time, uh, I think it helped me. It helps you get like that mindset of how programs work and uh, how you structure a program, really. This is like an interesting. That's something we can talk about later about like Pascal and C and Basic for that matter. I compare that to objective-oriented programming languages and so on. But yeah,
Interesting. Okay, so those are some of the influences, and I think we'll look back on those because they've informed the C3 development. But you mentioned after your schooling, where you're doing engineering physics, you then take your first set of programming jobs. Can you tell me what these jobs were, some of the things you're working on? I understand you're doing some work on gaming at this time. Is that correct?
not then. Not the first job. The first job was there was just originally I was supposed to um, come in, or I came into this new office that he had mm, established in Stockholm from a company that was actually in Uppsala, uh, where I actually lived. So I applied for the job in Uppsala. They had positions there, but I didn't get that. Got the position in Stockholm, and they had some product that there was like this add-on onto an existing product which is like monitoring stocks and looking at stocks, stuff like that. And that was like the flagship product. And this was some kind of analysis tool that was supposed to kind of look at that and predict things, right? Think about like the AI that we have today, but they didn't have an idea how that analysis was going to be, and they didn't have any tools. So that was like a total. The first thing I was like, have you? My first question was really like, this tool. Have you actually know that this is going to work? Um, that this analysis that you're doing is like going to predict anything meaningful. And they're like, doesn't matter. Just sell this to our customers, because they were like business, these kind of business customers that would just buy this really expensive product, and they just had this on top of everything, and they were doing like trading stocks and stuff. And I heard horror stories about like the previous version of that product, which it's predicting stuff, right? So we had run it on some data and it's predicting something, but the previous version of that product predicted different things from the same data every time it was running. I don't know how they ever shipped that, but they did. So yeah, and it was like this. It was so slow, this program. I remember it would take me like half an hour to an hour for it to complete something on a small amount of data and to predict some things. It was so annoying to debug that. So I kind of looked at the code and optimized it, and then was like running in half a second. Yeah.
Wow, that's quite a difference.
Yeah, and they were like, okay, that's good, but it's also good if it's like running. It doesn't matter if it's running slowly, because that way it seems like it's doing a lot of stuff.
Oh my goodness.
Yeah. Software. Oh God.
This is
Oh God.
a software disaster on many levels,
Yeah.
business and logic and
Yeah,
speed.
but that's kind of like this kind of selling to people that aren't good at um, really checking if the program is like really doing. I mean, this is kind of these customers, especially back then. This was like in 97 or 98 or something. Like it wasn't computers weren't as pervasive as today, right? So they weren't really like a lot of programs didn't work well. That was just like the thing. And like, how did you know that you should buy some program? Well, there were some computer magazines, but like maybe you were reading some business magazines and they had some, advertisement for some product and you bought it and tried it out. That was it. There wasn't any internet kind of, we had the internet by then, but that was like just in the beginning. So, uh, yeah, you could sell a lot of bad programs, I guess, you know. But
Yeah.
they were like in the beginning, I mean, in the 80s, there were a lot of shitty programs back then too. Like really people were selling all sorts of things, and some were just, just um, basically tapes with something in basic that didn't quite do what it said it would do, but it was just like it was very it was still very early, I guess. Like even in the back in 98, it's like still kind of early. With the internet starting to distribute like information, this is just completely different. So,
Yeah. I guess you get the accountability of the internet for one thing, maybe as far as does this product work? But I do want to touch on something, you mentioned about the performance, and I think this is still a theme of performance of software today. And I want to say there's a law or a saying, I think it's by Nicholas Fair, the computer science professor, who said software is getting as slow as hardware is getting fast.
Uh,
Um, what is your sort of opinion of the state? I mean, this might again be informing why C3 and we need, good systems languages, but is software getting better today? Is it just doing more or too much, or do programmers need to learn more? What's your sort of opinion of the state of things right now? Are they the
yeah,
same as in 1998 and prior?
well, I mean, it's so different because anyone who started programming in like the 80s or early 90s had the advantage of kind of going through that revolution where you have to all these new things coming that were like massive speed bumps and massive new ways of doing things. And also people were kind of working on products, right? So through programs. But like all of the time, everywhere, people have been trying to, one way is like I push the envelope and I make something new by being coding more efficient or some new idea or something like that. But then there's this kind of workhorse, not high quality, but people still use it kind of software as well. And there they kind of, get it out as cheaply as possible. And the stuff I was doing, that was like this, get it out as cheaply as possible. And for that kind of thing, it doesn't mean they don't prioritize anything that has to be do with quality or speed unless like the speed is actually um uh if it's too slow you can't sell it. If you reach that point, that's like you don't care. You don't care before that, but if you can't sell it, then there's a problem. So there is this, well, we just want this product, right? And we want to do it as with as little complications as possible and in less some standard way. We don't want to take decisions. Maybe we can't even make those decisions about like prioritizing technology and so on. So just jump to the part that we want to do, right? And we want to do is maybe like a website, right? And then they just take whatever is here and just, even though it's like this big ball of mud, it doesn't matter because people know how to build a website at here, but it's slow and bad, but it doesn't matter because they just want to do the product either as cheaply as possible or as quickly as possible. So and then there's also the concern about developers, what developers can I get and how cheaply and so on. All of that kind of ways in how hard will it be to maintain this product, how much will it cost, and all of these concerns are kind of making the people who are making the decisions, they are not going to prioritize stuff that they maybe don't even know anything about, like performance. And because it's kind of it moved software development moved from like very low level to very high level. I mean, I want a site, I want a site with our products and this logo. They don't care how, just do it. And when you come to that, it's kind of natural. I think this kind of, you fill out we use as much stuff here, this muddy thing, because you don't care, because you just want this part and you don't care about the shittiness. And it's inevitable. It's like that is essentially, unless someone forces you to do anything different, you're going to do this. But that means also there are advantages to people who actually can do something with less resources. So when you talk about games, that would be like I worked at bwin. So at bwin we had those poker servers. I was in the poker 4 project, and towards the end we could do like, let's say I think we had like 5,000 players per instance, and we were running like 2 instances or more on a single server. So we had a few servers, and that was just okay. So like say 10,000 players and maybe twice that many connections, and that was back in 2004, something like that. So if we could do that on that hardware, imagine now, in comparison, that's a huge gap. And people are like, yeah, I might have like 100 users. I need something scalable, and uh, that's just for me is that's ludicrous. Like you can do it, you can just have one computer that does everything, and it's going to be you're gonna you're not going to run into scalability problems unless you like put in all scripting layers upon scripting layers. Um, and that's of course what people also do, but they kind of deploy it somewhere, and then it's going to be scalable, and then they have all these layers and extra complexity, and then you have la 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 la, and then everything is very complicated just because they think they don't have scalability in this single small thing. But the truth is you just need one computer. Like this computer that I'm sitting with, it's enormously powerful compared to before. So I mean, just sorry, just do
Oh,
interrupt me.
yeah. No, no worries. I was gonna say, I wonder if, like you said, the accessibility of, Amazon or Google Cloud or Azure, you can scale so easily. Again, I think it goes back to that problem you mentioned earlier, where the managers, they don't maybe care and just say, well, yeah, just ship the product out. We don't care how you do it. If you need to just scale, by adding 100 extra cloud hours or whatever of compute, just do that. And that's worth the cost to folks. With what you just were saying, the trade-off of now your compute stack is not run on this machine, it's run on this machine with a scripting layer that talks to some other machine that you've never owned or seen. So the software story is complex now.
There's another thing, like because everyone is doing this, if you look at jobs right now, it's going to be like you have to know this whole stack, and then you come in and work with a lot of people, and they are used to do like everything they are doing for like now and in the future will be like in this stack. So they want to be in this stack because they kind of feel uncomfortable when they move out of that, environment of kind of, oh, I have Node.js and my npm or something like that, like this environment that you kind of live in. And for me, it's kind of like I hate dependencies. So I think this is just making me, giving me anxiety attacks just thinking about these layers upon layers, and then it doesn't work, and you can spend like weeks just trying to get something to work that is, in the first place, almost doing nothing. But it has done something somewhere for someone. That's why what's there, and then people kind of, yeah, just in case. It's like a lot of things today is like just in case we need to scale, just in case we need some logging, just in case we need blah 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 blah. So then we get like these very huge things. So it's like programming some product. So the way I like to do is like I write something, and then I go back, and then I clean it up, tighten down the code, maybe remove something. I see, I can, deduplicate this, maybe something easier that kind of handles that together. Okay, now I'm back, and I can add stuff again or change stuff again, and then we go back. But most companies don't want to do that, so their product kind of like just goes like this, and eventually this goes to like, oh, okay, we are adding developer hours, but we're still here, right? Or they say, oh, we need to rewrite, because they have this philosophy that they can't go back and fix things. And if there's no pushback from the developers are fine with just doing more stuff, then that's going to happen. And I think like a lot of developers are worried about saying, like, giving opinions to their superiors about things. So that was actually a problem back in, I'm going to go back into BWin because that was like, I was there for quite a few years. And I saw some, like, that was the first time I really ran into these things. So when I came there, there was like, no one would like, the boss would say, okay, or the project manager, we're going to do this feature. And developers like, oh, that's not a good idea to do it in that way and that. But they didn't say anything. And then it's okay, they and did it. And then eventually it was like completed, but it was good. And they got like scolded for like, why didn't you say anything about this? They didn't dare, you know.
Mm-hmm.
And I was one of these like could say like, this sucks. You can't do this. I won't let you do this feature. It's so bad. And you need kind of people who can stand up and say like, this is not good. This is, you have to do it differently. But then there's also this thing you have to be, like, you can't really be like, just be like, no. You have to be, no, that is not a good idea. This may, but what you really want is that this perhaps, then we can do it like this or cheaply.
Mm-hmm.
So you can have like a dialogue. That's the point. But since people are always often afraid of like kind of standing up for things, it just, the ball just starts rolling and say, oh, let's add another feature, and they don't feel that they have time to kind of refactor or fix things, so they don't get a culture of refactoring or fixing things and don't get trained fixing things, and then it just like goes like this.
I think that's a really interesting point with the development culture that you're touching on. Um, and I want to ask, how do we get to that point? Because the developers are supposed to be the experts, right? The folks who studied for many years and or worked at companies. Um, what would you say to a developer who has experienced this right now, where they say, we're using the wrong tool set, our code's very bad, and we need to spend a few weeks to fix it so it can move faster later? Is that just something culturally that has to be fixed, or what would you sort of say to an engineer who's going through that right now and in that sort of tough position? The management won't listen, and they say we need to move fast, fast, fast to get feature X, Y, and Z, and they're saying the code's broken.
Yeah.
Effectively.
It kind of depends, because it's not, I would like to say it's not clear cut, because sometimes, I mean, if I say, okay, you should always say like, no, that's not necessarily right, because maybe they're just doing something. There is some reason why I have to move fast, like some actual, the competitor is going to win otherwise or something, and you're going to be kicked out of the market. Or it's just like, oh, it's just not important. The thing is not important enough. So they could just as well throw it away if they know like, oh, this is going to be too expensive, just throw it away. That's like, it's like, what do we need it for and how important it is. I think it's important to have like the conversation and dare to do that. I don't ask people because that to do that because it's like a very your personality and stuff like that that will influence things. But try to keep one person in a team that does this like for you. I kind of, because I was like saying no, the other ones that work with me can also say no, but slightly gentle, more gently. It's like, no, it's bad, and they ask someone else, do you also think it's bad? Well, yeah, it's might be a little bad, and then that kind of, I could defend them in that, because I was mm, personally, I went into things like with a I don't care if I get fired attitude. I didn't get fired. I was very popular despite that. um so I think that they appreciated like this, to really know about these things. But it's also hard to just like, some people come out as just whining, everything is mad, and you don't seem to be constructive at all. So the hard balance is that kind of, can you be constructive and say like, this is bad, this is what we should do, and also quantify it, like this right now, this might cost 1 hour or 1 week, and but if we do this feature, then next time we're going to have a delay of maybe like a half a week, to just because of this is going to add, and half a week later to the next feature we do, and the next one will also be delayed by like explain how development works, because they are not experts. And even if they maybe were programmers at some point in time, they might not know anything about like the particular domain that you're working in. So try to do that. Like even if you can't say no, you can at least say okay, and just be aware that this might delay things. Just give a hint. The worst thing is just like not saying anything, because you get scolded even worse afterwards when they discover that this is true and you know it from the beginning, but you didn't say it. So that's worse. But also, there's one tricky thing about refactoring and fixing things. So the tricky thing is when you get the buy-in, a tempting thing would be like to refactor too much, right? So there is also, this is bad. I don't like this. Let's throw it away and like build something new. It could be a small thing you're throwing away. It doesn't matter. It's not the throwing away part. It's more like let's get ahead of ourselves and do more refactoring than you really need. And because then you're actually lying. Like if you say, I need to refactor this for, a week, and you do the refactoring that's necessary, but you also do something else that might take more time, and maybe there are bugs in that code and so on. So you have to kind of have that balance and that maturity. So it's, I also recommend people to kind of not get ahead of themselves when they refactor. They should, one of the most important things though, this like keep the code readable, right? So the most important thing is like not that it's the perfect solution, it's that it has to be readable. And a lot of the clever solutions that people think about, those are the worst ones. Like you have, I can solve this, I can save a few lines by doing this, adding this like small thing that will do reflection and did. No, don't do that. Just have it really plain and simple, so that next time, like if you come there in 10 years and have no idea, it's like, yeah, I was just doing first job, second job, third job. It's not like you put in a provider and an array, and then that thing is going to run your things by reflection and looking at the names and so. You, you do that and then you regret it. So clever solution also should go. And I think like the worst thing about the new, like all the software stacks, is a lot of these, tools are clever like that. So you have, you register somewhere here and then something here and something here, and then they together kind of assemble something behavior. So if you're just a programmer starting out, you can't just go and read the code. You have to learn the frameworks. And I kind of hate frameworks as the framework idea of like, this is a framework is really like here's the framework, and your program is just going to be a plugin here that's going to fit exactly right. And the problem is like if you are a plugin and you want to use another framework, it's just like, how do you do that? So that's why frameworks like tend to, over time, if they get popular, can get things so they can connect, so you can still put your thing in and get both of them. But that's a problem because you're using frameworks. If you're using libraries, this is your program, and these, like the small thing here, these are the libraries that you use, and you don't care what they are. So the whole thing about frameworks is also, I mean, one of the primary bad thing about programming today. The OS could have a framework, right? The OS is not special. I mean, your program is going to be like a plugin to the OS, right? If it's that is a plugin, that's like the definition of it. But you don't want more plugins. You don't want to be a plugin if you can avoid it. So, but people love to write frameworks, because when you write a framework, it's like, yeah, I'm on the top of the hill. I decide everything, and I'm just going to do the easy parts. It's actually just often just doing the easy parts, but you have to think about how the heck you're going to use like the hooks you have to like poke the framework in the right direction, so that it times things exactly and behaves correctly. So I think today the problem is is like this framework mentality. Um,
Yeah, and I think with the as you mentioned, I mean, just the landscape with, again, frameworks can be sort of very useful for getting up and running fast. And again, maybe that's the right thing to do, as you mentioned, and I'm glad you mentioned sometimes there's a business decision behind this. Otherwise, yeah, the company fails and no one wins in that situation. um, but the sort of temptation to have lots of dependencies and kind of gluing frameworks together can be um, tricky long term. Um, something I learned from another developer, Titus Winters, talked about how, and maybe this is a tool for software developers to have these discussions when you're writing code or implementing a feature to discuss how long they think that feature should live, and maybe that's or that particular code, what's the lifetime, and that might inform some of these discussions of, well, let's rush because this feature is only something we're trying out for a month, or if this is critical, yeah, let's slow down and really think about and talk with our experienced developers about what we should do here. So I wonder, during your software development time as a team, did you have those sort of discussions of how long is this code base going to live, or did those things ever come up that you recall?
I um I think I mostly lived with code bases that I want to make them live forever.
Mm-hmm.
So I've worked on I mean, I think like most of the time as a programmer, I worked on code bases that are like legacy systems.
Mm-hmm.
And often they started out as more legacy and then we kind of brought them to a normal system kind of status.
Mm-hmm.
So you kind of this takes could take years of refactoring, like slowly refactoring things. So you start out with something that kind of works, but it's bad.
Mm-hmm.
And then when you're going to do a new feature, you can perhaps find that you can replace that whole part with something new that works correctly. And then you work yourself through the system. And I had one backend that I worked on as a consultant for, I think, 10 years or so. And that was a PHP system too.
Oh
And it was
wow.
not, there weren't like, there was like, originally that system was, I think it was based on having like a lot of code gen. And then someone wrote, like they wrote like a simple kind of frameworky thingy to get, to serve pages with routing and stuff like that. And I think they had like an active record and some routing stuff. Um, but the old things were all there. And when I came in, developers had been going in there and they just left the old things, the old bad things. No one wanted to read that code and understand how it worked. So over the years, it kind of feels like digging, around this thing or operating, slowly, cutting out that part that should be removed, and then like making sure that we have things around it that does all the stuff that it does, and then you can just take it out piece by piece. And I removed all that. It's like it was even the routing was like, let's replace this with a simpler routing thing because it was originally just both serving front end and back end, and then front end was removed and there was like a special call to the back end and stuff like that. So we didn't need the front end, so that had to be removed as well. So but it's possible. Like if you do really do that, like you care enough that you actually read what the old systems do, not just, oh, I'm in a legacy system, it's bad, and let's just put my piece on top of things like a boil or something. Oh, and and yeah, now this code looks even sicker, but it doesn't matter because it was already bad. People were talking in those terms when I arrived. This poker server that originally was like, no, we can't, it's so unstable. And over the years, we just fixed all the bugs.
Mm-hmm.
Just fixed the bugs, and we just fixed everything and added all the features that they thought they would never be able to add.
Mm-hmm.
So it's possible, but you just have to have patience and know one thing too is actually caring about fixing bugs. So
Mm-hmm.
a lot of people don't like fixing bugs. See, I like fixing bugs. That's why it's not a problem. So,
I can
um,
see why folks like working with you then.
uh,
A lot of
so
folks run. Yeah.
yeah, so it's very educational to fix bugs. If you go into a code base, you don't know anything about it, and you have to fix some bugs. If you don't know anything about the system, you have to start just reading the code and kind of think about. You can't just apply something on top of it. Like, let's pretend it isn't there. Some people would just like, oh, it's there's an exception. Well, if I do a try catch around this, it doesn't show. What? Bug fix. No. But doing that, it's you kind of. I think you have to improve really. You have to learn how to like everything
Hmm.
or enjoy every part of the programming, more or less. I mean, you can enjoy some things more, but I try to find something fun to do, whatever the task is. So regardless of what system I'm working on, it's like a business, something very dry, or some game. It just doesn't matter. It's like you find something interesting in it, and that is I mean, enjoyment all ultimately comes from yourself. It's not external to anything else. It's like you teach yourself, yeah, this is interesting, this is fun, and it becomes that, right? So fixing bugs, that's interesting and fun, and you can get like this enjoyment, and now it's gone, and now the code looks more better, and the things work nicer, and the bug count goes down, and you can feel enjoyment from that. So take enjoyment from that. So I think that I know some people that I know that struggle improving, they dislike some parts of programming. So they would like try to avoid that. But I think in doing so, they just got less exercise in general and kind of in terms of programming. So uh,
Yeah, I think that's a really good point. I mean, you've touched on a lot of things. Oftentimes when I've seen new members added to a team, the first thing they're assigned to do is fix some bugs, and that's a great way to learn the system, right? You pick out some reasonable bugs, but yeah, it's also important for the senior developers or everybody to fix bugs and not avoid that code that's rotting and that everyone's afraid to touch because it's too unstable. I think that's a really good reminder, like you said, just there's probably an interesting problem there if no one's touching it. So you have to find a way to get interested and take on that challenge and enjoy that process to improve. I think that's a excellent reminder to us senior developers as well.
I mean, this thing with refactoring code that is broken, that is super interesting because it's hard. That's hard. It's very hard, and it can be like this is kind of I have migraines sometimes, and when I did some of these like massive refactorings that it had to be like really big, it would touch on so many systems. I had to keep all those systems in my head at the same time. And then after a bout of that, like 8 hours of that, it was like, oh yeah, I'm having migraine coming in on because of just you have to concentrate so much. But well, it's very challenging for everyone, I think, to do these refactorings, and also you have to be a bit brave in doing so, and you have to take responsibility. And one of the things, or something that think is lacking some developers that's bad is when they don't take responsibility for testing their stuff. So they kind of do their stuff and then whoa, bye bye, and they might not even have run, like maybe it's compiling now, it's done or something. So I mean, if the code is not tested, then it doesn't work. It's like that. It's just, but they don't do that. I've been like someone Friday afternoon, like, oh, I deploy my stuff. The logs are starting to just scream stuff. And it's just this guy is just left, and he's like, yeah, I didn't look at the logs. Always his programs was like his check-ins were just random just screen logs, obviously super easy to test, but to just check. I mean, if you do a checking, you do a deployment, you check the logs to see that nothing's bad is happening. Nah, someone else takes care of that. So but that kind of thinking or downplaying bugs is also one of the things. Like, yeah, it's a bug, but doesn't happen that often. I don't want to change my code. It's just running, and it's working. People who defend their code, that's like a red flag for me. Like if you say, yeah, my code is good, and then it's like because I don't think my code is. I mean, if you meet someone really good at programming, that person's gonna say, "Oh, this is my code, but it can be improved." I did it. That's yeah. There are always places where you can make it a bit better. Like if it's non-trivial, if it's trivial, of course, like a Hello World, it's like not that,
Right.
but anything that's more complicated. So. But if they say like, don't change my code, like this is fine, then there's a problem because then they're not even thinking about their code or what could happen. So
Yeah, and like you said, it's got to be the complete developer. So not just writing your code, you have to test it, you have to fix the bugs. And I think there's been some culture for a while of there's the programmers that write the code, and then you have the testers who just write the tests. And I think that's disappearing a little bit, where we've decided, yeah, actually, if you write the code, you should write a test or write the test, first, or different strategies. So it's kind of interesting to see, I guess, as we're learning or different companies learn about these practices.
yeah, I had some great QA. That's like the best QA I have are the ones like if I when there is some obvious bug that you should have, they come like looking really pissed. They're like, "Well, I found a bug with your code," and it's like, "Yeah, sorry." So that's kind of pressure, the kind of pressure that makes you want to kind of excel, right? So you don't want them, you don't want to feel very. I mean, it's kind of the kind of I am disappointed in you, that kind of feeling. That's the best because then you kind of get that feel ashamed, and next time you're going to do better because you don't want to feel that kind of shame again. If they're really angry, like really angry, then you might feel like defensive. But just this QA should kind of expect that everything should work. Everything should work, and if it's not working, then QA can go to like, look, you added a bug. That should be like the relationship. So QA should not be finding bugs, and the developers should feel that they shouldn't create code that has bugs. Then exactly how you test your code, that doesn't really matter to me, but you should have tried it out. And some people have, yeah, like you also have to have something I've seen missing is like people don't have same development environments. So they often they like, oh, well, I can test. It's like you develop deploying this there and then something there and then something there, and that takes like 10 minutes, and then I can see results of my tests. That's like not a virtuous cycle. That is bad. So if everything is it should have like, okay, I trust it, and I just can jump into whatever I do and test it and see what happens quickly. That's the kind of feedback you want, because otherwise you won't do as much testing. And you don't have to do like, it doesn't mean that you have to do like, oh, you have to do unit testing, this particular unit testing or something. You just have to check. You have to be comfortable with saying like, this is good enough to ship, and that's why I said it to QA, right? So that kind of mentality. But God, development, I mean, their environments are so awful most of the time. That's another thing. I think that's also affecting, quality of the code. When they don't even know that it's going to break until it does that live, because they don't have that setup. And that's something managers can't really decide on. That's just something, I think there's like a kind of bad culture with programmers thinking that it's good enough to have something that takes a while. It doesn't need to be like fast. I mean, even if you have like, let's say you have unit tests, you can have like a million unit tests. It doesn't matter if because if that running those tests are not slow, then you don't want to do that. You can't do it quickly. So you need to
Agreed,
have
100%.
that thing. Yeah. So it's a matter of whether you can, quickly look at things and see find the bugs. Um, then if you're good at programming, then you can start cheating because like you only change this like small thing, and so you only need to do these things, and you learn how to like scope your work to just be here, so you can do less testing. But that's more. I don't think people can just jump to that. That's more of a learning thing.
Mhm.
But just you have to have that feedback, just getting back and can experiment and just do something and see it immediately. That's so great when you have it. And that's what I hate about like C++, by the way. So the slow language like the Swift as well can be super slow. I am not doing anything in Rust, so I can't like say anything about that. But that kind of and just slowness that's everywhere. I mean, it's in web development too, because they have all these environments, but that's kind of avoidable. And in when you do like C++, you really have to avoid anything C++ and to not have those long compile times. And if you have long compile times, you do less work, basically. You can't work as quickly. And that sucks. And it's just
Yeah. And that's a whole art, speeding up C++ builds and limiting your dependencies and these types of things, which unfortunately we have to know, or some people don't know, or but maybe that's a good transition to start getting us towards well, one thing I want to talk about first, I guess, is the handmade network, because we've talked about frameworks, and then there's this handmade network, which if folks don't know about, I want to give a shout out. And I would say these are largely developers who like building things from scratch, many times in systems languages. There's lots of folks doing language development, like yourself, who have various blogs and are on the forums there and so on. Um, but what do you notice something different about the quality of code from folks who are kind of doing things from scratch and building frameworks, or are part of handmade or similar other networks? Because there does seem to be a sort of care or something that's different there that I've noticed.
yeah, I think they kind of lots of them are um, off, awfully smart, actually. They are doing great stuff, and it kind of several quite young people are doing amazing stuff. And I think it's also, you know, this goes back to kind of, I have to connect this to my own experience. So I would, I mean, when Java came out, I had some, did some course in Java when it was like released, like 1.02 or something. I don't remember the
So
first
this
one.
is like 90, mid 90s or so, around.
Yeah, 90 could have been like 97 or 96 or something. I don't know, remember. And that was awesome, and you could do these. You had these old browsers at the time, right? And you could do some games, and I was like, oh, a new world. And I'd learned C++, but not really used OO. And in Java, you're like, yeah, you have to use it. Um, and then I didn't really have to. I used it a little professionally I think in 99 or in 98 or 99, so something like that. It's like the dates are kind of jumbled, but uh, it was a lot of things were kind of confusing to me at the time when using O because you have to think about it differently. And kind of eventually I managed to kind of know how to do O. So maybe let's say my days at On Game B when there, I could actually be productive doing that. Uh, but it was still kind of, some modeling was kind of hard to do. And it wasn't until I had like played around with other programming languages, and I was like writing a server, a game server, and I did it in Ruby. So Ruby is OO too, but I did like, I had this game state. And the problem was, if you have a game state which is kind of complicated, with a lot of players, and you have like this thing going in, a request, so like buy something. And then you have to check, okay, do you have enough money for that? Do you have room for it? So you have all these checks that you have to do. And if it fails, you shouldn't do the whole thing, right? But that means kind of you get this, if you miss something somewhere in these kind of rollbacks or something, then you have something, a bug in the game, and people can exploit that. So if you have 3 of those, that's fine. But if you have 50, it's a problem. So I had an idea. Yes, just played around with Ruby, which is, I was saying, I could do this as slow as I want. So what I did was, let's just keep the whole game state in like this nested hash map. And before doing anything, I was just serializing the whole thing to like a blob or something. And then you did the operation, and each of these operations had basically an exception or error result. And if there was any error results in anywhere, then I just rolled back everything, right? So I just restored the whole state. So even if I had done something incomplete here, it doesn't matter. Even like messages, sending out messages, things, those were also into this. So any messages being sent out to other players, something, they're also rolled back and removed from this queue. So that was a real simple way of thinking of it. Like, here's the data, and here are these functions that are actually acting on the data. And that was the only reasonable way to model it. If you did what I thought I was doing when I was younger, like, oh, let's have this. Oh, here's the model of whatever, like this village, and it has these prices, and it takes, it's just going to be like these pieces of state everywhere. And then how do you roll back something, a network of things? You have to kind of know how to serialize and deserialize it. So what I did, eventually I want to port this to Java. And what I did was, okay, I still have this hash map. This is just this tree of things, but you can still just, okay, you grab this part of the hash map, and then you do a facade, which is some entity or something, and you can have like methods on that and do things, and you still do the kind of rollback. And you could do it very simply, yeah, like the cheaply, the rollback, because you don't have to serialize it, just store what you need to roll back. And that was super simple, and suddenly everything worked. And that was just removing all the OO, because the OO would have like put everything, oh, here's a map, right? But the map has a village, and the village is an object, and it, put those pieces. One here I had a single data structure, and I could serialize it, everything, could synchronize it, I knew where everything was. So this was, oh, we are just doing functions that are mutating some data. And that's what we're doing in OO too, just making it more complicated. Because we have, like in OO, you have that first thing where you need to architecture things and decide where things go. And you don't have to do that if you do like go back to Pascal and C, because then you just solve the problem. Just, okay, I want to print something. Well, then you print it. You don't think, oh, I'm going to call this printer object that's handling printing for me, and I'm going to make a call, or I need to request that printing thing from this other container. Just print it. And I remember university had some Turbo Pascal, and I would writing these online doors. Before we had the internet, we had modems and connected to the VBSs and stuff like that. So small games, right, for those. And I would just throw out, very simple ones. But those were really simple. I didn't even think about like architecturing it. It was just, you could just do them. And when I think about like doing that from an OO perspective, what the first thing I was thinking, like, oh, where are things how do I put them and separate them? A completely unnecessary step, because all you had could you reduce it to were a few functions. And if you look at a lot of old codes, it's like sending some message around and maybe picking up something data as it goes along this web. And so there are these autonomous kind of robots that are talking to each other with state. And that's super complicated. So it's not wrong to kind of encapsulate state when it can be encapsulated. So like if you have a string object, you don't need to, it can encapsulate whatever state it is, you don't have to know what the representation is. That is a fine encapsulation of state. But basically say, let's do that for everything. And that's just a problem. And then you get like a super unproductive, and you don't understand what the program is doing either. And you get like, this is just balloons into a lot of architecture that you're not really ready to do. I tried to teach someone Java. He had done MATLAB and stuff like that. He couldn't wrap his head around OO. Like, why do we even have that? I say, yeah, actually, this is completely unnecessary for what you want to do. But that's just the way we do it. That's the way you have to do it in Java. So the OO tends to add this complexity. And once you tear away that part, that kind of work that isn't really work, and just focus on learning program. So sorry, so it's a long story. It's like now I come back. So once you start actually practicing, writing C, writing kind of C like C++, writing things like something like Pascal. If you do that, you just go to the meat of the stuff immediately, and you get a lot of practice. If you just practice on doing these things here and doing encapsulation and things, you get good at doing that. You get good at like having super many layers of things, but you don't know how to tackle the actual problems. So you get also, it's kind of back in the days with BASIC, you wrote your little program and it would do something immediately. And once you have to go over these frameworks and blah blah blah, suddenly you feel like, oh, I have to do all these things to ask what my name is and then print that. Or it's just like, if I just plug things into the right thing, I can maybe get that, but I don't know how to do it for myself. But if you do something like C, you can just do it. And you practice on the right thing. You actually practice programming. And then they get good at it. It's like well, I think that's the reason. Like, that's what programming should be. Now it's encapsulation can be good. I mean, stuff like from O can be used, but it's just, you have to focus on actually solving the tasks, right? The hard tasks. And once you do that, you can do a lot of stuff. It's easier than you think once you just go functional, or like procedural. Just write your program, and here's a function that you call, and writing something like, okay, I have this guy on the screen, he runs around and he can shoot things, like something like that. It's not much code. It's you have to have some loop where you do, so you can continuously move stuff. But it's very little code. If you look at you look at an example doing Raylib, so you can avoid the graphics, outputting graphics, thinking about that. But it's very little code in the engine. So I think people who kind of get scared of doing things that seem hard if you would do it on OO, but they are so simple when you do it just procedural. So I think that is the problem. That's like the problem for a lot of people. And if they find the way to kind of start writing things, they can discover that, well, this was much simpler than I ever imagined, because they don't have to do the architecture stuff, which is super hard and requires a lot of experience. And if you do it wrong, it's just it's so hard to maintain. But they think that's what everyone does.
Yeah, it's very interesting. And I mean, the full disclosure, I'm a professor for folks who don't know, but in universities, we sort of teach I think sometimes we start it off right where we teach maybe Python or C to someone just learning, and then like you said, we add a lot of complexity with object oriented this and that when I think if folks understood how to do object oriented programming in C, that would be very insightful so they could see what they're paying for when they add object oriented programming and maybe sort of over architect something. I don't know. That's kind of a hard thing maybe to teach or to show. But it's something I do think about carefully when I'm teaching, for instance. Because it's fun to show all these different features, but like you said, it's very easy to misuse some of these and say, well, this is, whatever patterns, we're going to wrap everything with objects and getter and setter functions. And like you said, this could just be a function, calling into some library, and it could be as simple as that. And that's not wrong, right? That's probably the right thing to do.
Yeah.
Things.
So it's kind of sad that everything is going into these patterns, because now you are expected to also do these things like in that way. So it's getting increasingly harder to just do it simple, because basically even on the kind of OS framework level, they kind of decide that, yeah, you probably want to do it in like this more complicated way. So yeah.
Yeah, I mean, I fight this battle, but yeah, computers at the end of the day are data in, data out, and that's exactly what when I use C or C3, right? I think about, when I'm programming, it's just a data problem. How do I take this blob of data and transform it? But with other languages, like you said, you have to think at a higher level of abstraction, and you kind of lose that message of data in and data out sometimes. With experience, maybe you have it as a model, but it can get cluttered.
I think that the one of the things about OO is because you have to like O is like a lot of things that what we don't want to do in programming is to get ahead of ourselves and kind of lock ourselves into a solution that
Right.
later might turn to be wrong, right? And so you want to do like incrementally exploring the problem space, and be able to kind of build it slowly and safely, kind of incrementally, maybe doing this part and this part. And um, OO kind of says, oh, you can do that, and you have all these tools with interfaces and stuff like that. But OO has this tremendous upfront design. As soon as you put things in one, like here is one object that has some data, and here is another object that has some other data, and then you decide this data here should go in there, vice versa. And that is a huge change in the code base. So you have all these like interface programming towards the interface stuff to make that kind of easier. So you have all these refactoring tools, but you don't need them if you write procedural code. So these are basically solving, like making the problem a little easier to solve, but it's there just because you already did this upfront design. So it kind of creates a problem for itself, then have to solve with their tools. And then people are saying these tools are not available in like C. Yeah, but it's not necessary because it's because of this upfront design. And the other thing with upfront design, even though you have these tools, is that you're going to be like, okay, I can refactor, move this to that, but that seems such a pain. Let's just keep it like that. And you get all these bad decisions kind of hanging around because it's hard. It's kind of it's stuck in there, and moving them around is really hard. Whereas it tends to be in plain procedural, there are no like they are not strictly defined like that. And you don't have to like, oh, move the methods. Oh, the methods were all here, and then you go here, because you have the functions. Just call the functions, and it doesn't matter where you place that data exactly. So you have to make so much fewer architectural decisions when you do just C code. And you can do them also often easy. It's often easier to kind of, okay, this part here is this layer and has this data. And it's kind of more actually isolated than doing the same thing in perhaps Java, because the objects kind of tend to want to be connected to each other some ways, because they want to propagate information up and down. So this layering, like think about like a compiler which has like certain parts and like these things are easier to kind of isolate from each other than what you see in, looking at Clang, for example. You see these things leaking back and forth, because and then you end up, oh, I maybe need this thing, and it's kind of unprincipled in a way that maybe someone intended for these objects only to be used after this limit. Like you do this stuff, and then after here, you just use these objects or types. But it's very easy for someone to like, oh, I could need that one here, and thus we pull in that part here, and that's so hard for someone, like, first of all, the things are not really communicating this dependency here, that these parts should not be in any way dependent on this part. And it's also easy for someone to just borrow things from here in a way, in an unprincipled way. It's not easy to detect that because you have so many of these things floating around.
Yeah, so this is probably a perfect sort of transition to get into the C language, C2, and C3 even. C3 is your language. So, at this point in your career, or at least we've sort of gone through your many years of experience. And as far as I could tell, I found a blog post from almost 4 years ago where you're announcing the C3 project and the Handmade Network. Can you tell me just a little bit about what inspired you to just start with the idea of writing C3? When did it start? Was it more than 4 years ago? And what sort of made you have that aha moment, which said, I need to, write C3?
Well, I was back in days, I was looking at different programming languages around when JI. Still, no one knows how to pronounce that. JI, yeah. And that was like 2014, right? When that was the first way to come out. That was super inspiring, by the way. It's like, I think like the SIG creator, he must have been like super inspired by that. I think that like looking at early Vegas, I'm sure that's where the inspiration came from. And I was looking at to satisfy my thirst for ideas of programming languages. I was looking at different programming languages at the time, and I had seen like C2. So C2 is a programming language which it says like, okay, C is really good, but maybe we can, improve it a little bit because we're going to have C for the future too. Like, no, C is not going away. Let's keep it to C. And it's at the time it would transpile to C code, good C code. So you could essentially write C2 and then have it output C code that you could use. But that was like in the back of my head, and then I think this was later. I kind of, I think I was still following JI and looking at crafting interpreters. Yeah, I found that one as well. The Bob what's not Nystrom?
Bob Nystrom?
Yeah.
Yep.
So and for that one, kind of, I liked programming languages. Actually, even further back was when Swift came out, and I was like looking at what could you do, like if it didn't have Swift, how would you improve Swift, or could it be like an Objective C3 or something like that? And there were a lot of people thinking about programming languages with Swift as well. So it's kind of hazy to me. Like there was there were, language thoughts, but I was more OO, doing more OO code there, and than I would do today. Um, kind of really unformed ideas. But okay, so fast forward to like 2016, 17 or something like that. I felt like, yeah, I would like to work in a programming language, but let's face it, there are too many programming languages already in development. So maybe I should just, because there was nothing, right? There was nothing. There was no code. So maybe I could just, contribute to something. It's like everyone wants to do their own code. Let me be different. Let me just contribute to something. And what should I contribute to? So what language of these new ones should I pick up? So JI, that's closed, and there was SIG, um, and then some old ones, and then I saw C2 as well. And to me, looking at C2 is like super easy to read. You could just, okay, I can just read, understand, and just start, and just looks very friendly to me compared to SIG. So SIG has a very like this very, what kind of drives me away is kind of these very Java-like or C++ or Java-like thing where you have like dot, 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 you have long paths everywhere. I find it extremely hard to read. So I felt readability was low, and I was like, C2 looked good, and I compared like equivalent examples like base 64 conversion and stuff like, yeah, I could understand C2 and just like, yeah, I like C. So so I started contributing to that language. So I did some things, and I had a lot of different ideas, things to add to the language as well. Most of them pretty bad. So it was good. I like Bas van den Berg, so who is the author of C2. He was like, no, this just has to be like C. So just too far from C and stuff like that. So it was super good. But unfortunately, I didn't feel like he didn't have really time to work at the language at the time, and the kind of the 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 community was mostly gone. It had been gone up and then kind of gone down. And I was so keen on doing these things, then I would have to wait until like I have done some feature. I'd have to wait like maybe 3 weeks for him to look at that pull request or something. So I was thinking like, oh, I wanted to try all these features, and it was supposed to have semantic macros, but it hadn't made anything like that. So at the time was basically just C with new syntax and modules. So modules and slightly modified C syntax, but other than that, it was C, and even with the preprocessor. So I wanted like, what if I just write a specification? Like imagine like I call it C3 and it's like, yes, what could we have? Like, what are my ideas? Just took even his format of writing examples. So the original C3 kind of thing was basically like C2, but having examples in C3, which was just like a code name for some additions to C2. And I had like this chapter with crazy ideas that I didn't know if were good, and some like I tried to kind of sketch the programming language basically with all the examples, with all the how it should look like. And yeah, I felt I wanted to do something in my spare time. So I was like, maybe I could, maybe I could do like this tokenizer for this. Like maybe I could do something. I'd done parts of a like the parts of a C2 compiler in C, just the beginnings of it. And I asked Bas, could I do this? Like I start with my own language, I call it C3, and like, just is it okay with you? And he said, yeah, I can do that. So that's how it started. So I started with a tokenizer. So I built a tokenizer and I built a parser, and then I built more parts.
And then it just kind of drew you in, and then it was time before you know it, you had a full language that was compiling, I guess.
Yeah, I also wanted to, try to integrate with LLVM because C2 was supposed to do that,
Mhm.
but there was like I found a lot of things missing from the front end data to do that, and it was hard to kind of work out how to do that. Uh, Also, the C++ API for LLVM was super confusing because you have like this big, and you can basically do anything to LLVM objects. But when you go there, you like the first thing you want to do is like, yeah, I just want to declare a variable, right? I just want to have a function. And then you have to go through all the documentation, like maybe find something and figure out how to do that. But the C API was like, yeah, you can we only keep like the important stuff that you have to have. So it was super easy to use that in comparison. So for the C API, yeah, you could do everything. And there was something like I think with like ending some block, and you couldn't do it. You couldn't generate blocks in the way you would do it where they did it in the kaleidoscope example. But it turns out the C API function would also automatically do everything, like several lines of code that you needed to do anyway in a sequence. So it was just really good defaults to get you started. So I could get that up and running. Um, I don't know at what point in time it kind of grew into, okay, let's do this as a separate language. Um, but now it is.
Yeah.
It's just happened.
And as mentioned at the very start of this, it's a language that's getting, more and more attention. Um, but I wonder if, even along this process, I was looking through your blog and I saw some different entries. There's one even in 2022, which I'll link, which is, the case against a C alternative that you had. And I was wondering if, you're building this new language. Was there hesitation and, will this be successful? And but you keep working at it, right? As we are now in 2024, and it keeps gaining, a little bit more momentum, more momentum. Um, but a compiler is a challenging project. So how are you persevering to keep adding features and go beyond a tokenizer to, parser, code generator, and onto a full language? What's the sort of motivation here?
Well, it helps being like very self-motivated and just I mean kind of I've learned how to you have to I've worked a lot remote, so you have to
Mm-hmm.
keep on, doing this and just have to motivate yourself and just do it. And also know how to pick up out small pieces that you feel are enough to complete at a time. So you can't build like thinking I have to do all the features. You have to make small things and then see that work.
Mm-hmm.
And then you get motivated to add another thing that might work,
Mm-hmm.
until it's all done. Um, and just I kind of don't think about the end goal. I just keep on doing it, and just kind of enjoy writing code. That's all. So
So,
yeah.
so maybe I can add a follow on there because you mentioned Jonathan Blow's language, JAI or JAI or whatever they're gonna call it, and I think that language is sort of for his game development, and they're sort of a driving project. I wonder if you had in mind too, while developing C3, other driving projects or projects that you want to complete later in C3 that are either kind of informing how it's being developed or just maybe from your past experience, just thinking, wow, it's going to be really nice to build games in C3 or servers or whatever application. Do you have sort of a project in mind that's driving C3?
Actually not, because I understand the question completely, and I've been thinking about like should I do something in in C3. But I think like the thing about C3 is that it doesn't say, okay, C is bad,
Mhm.
let's get rid of C. It says C is good, and let's see if we can enhance C if we would be able to kind of don't have all the backwards compatibility with like existing code. What would we be able to do? What kind of features I can play around with? And that was like the original idea from Bass, and I've probably gone a lot farther than he thought was good. But it's still there in kind of I can just write C, and I'm happy writing C. And I didn't answer this question before because I was supposed to. Like, why do I think about like why do I write C3 and think that yeah it's okay to write this language and why do people use it? And my thought is basically this is an experiment. Okay, so I try to make a language that is C with other stuff, knowing like I wrote in the blog, all the problems with going away from C, like migrating to another language from something with all the tool chains, everything that's like C is everywhere, and you can do everything like in every domain, and it has so much knowledge built in, handling these different domains as well. So can I add enough value that is worth to a significant amount of people worth going to C3 and they get enough benefits? We go back to the thing with like companies and this is beneficial for me to do this or not. Like everyone will have that kind of equation. Why is it beneficial? Maybe some people go into a language like I'm going to be first in this language because then I get a job, job security. I'm going to be first doing this. Some people, I'm sure, do that. It's a tempting thing. Then it's kind of be a betting thing. Like, yeah, I go into Rust or I go into this, I go into this because I'm going to be first. And that can, pay off. But for C3, it's not, I just want to make it good enough, as good as I can make it. And then I'll just see. Is it also bringing enough value? If it's not bringing enough value, then why should anyone use it? It's not, I mean, it's better use C with the disadvantages. So I need to bring enough to see. And I just want to see if that's possible or not. And also like there's this difficulty here is still like, can we still not be too complicated? I mean, you can add a gazillion features on top of C, and then say like, oh, I have all these features. You can do it for these features, but that's not the same thing. Then you're building something completely different for some completely different domains. You're not building C really. You're being like this big language, and I guess like D is like that. It's like it's a very big language, and it doesn't compete with C because it's a much bigger thing. So then it competes with like C++ and something that tries to be like a bigger thing here. But if we go down to C, you have like these constraints of you can't add too much stuff, so you have to only add the good stuff. Like, can I do this like add good stuff? Enough good stuff that actually it is worth going away from CM. I don't know. So, but I'll try. And if it's not possible, then yeah, then C is good enough, and that's okay because I like programming C too. I mean, compiler is C, and everyone's like, no, how can you write that? Some people are like, look, how can you write the compiler without pattern matching and algebraic types? So it's not possible. You have to write it in camel. So some people have different opinions on what's needed for programming, but I enjoy that a lot. I like how C kind of forces you to reevaluate, and the lack of abstraction is helpful in many ways because if you have a language with a lot of very high level abstractions, you tend to go, just like you tend to go for a framework, you tend to go for those high level abstractions. So let's say you want to see something. Oh, is there a duplicate of something? And well, if you have a simple abstractions, you have GC and so on. Oh, let's just create a hash set, and then you put these things in, and you can look if that string is there or not. But maybe there were just 2-3 entries on the average, and that's not going to pay for that hash set thing. But you can do it very cheaply. But you can also do it maybe just by iterating and doing comparisons. Maybe that's faster because maybe there's just one thing to compare with most of the times, or 0 things. So, or just you can just reframe the problem and not having to do that at all for some reason. So it was sometimes hard to write a compiler because like in that kind of sense, you had to think about like how to frame the problem differently, so you didn't have to do anything complicated. And I deeply appreciate that, because it's the simplicity isn't just okay, that's simpler to do in C, but it does means also often it means that it's more straightforward and less things cluttering around, because I have had to make an effort to kind of focus that. But even that said, okay, C is verbose on doing a lot of stuff. So there are things you could add to C, but it's good. so
Yeah.
yeah.
So you sort of, I mean, when you think of the language evolution, are you looking at what's going on with like C23 and additions going there? Are you looking at other programming languages to kind of tease out what are interesting things to try? Or just your kind of previous experience where you say, well, here's some C code I wrote, and it'd be neat if we had this particular feature in the C3 language. How do you sort of think about the language evolution over time?
Oh, this is something I don't like. I don't consider myself a good language designer, so I can't like just come up with a language design. And like if it had been total free form, it wasn't based on C. I just write a language. I maybe now, like when I have a lot of experience, but at the time, impossible. So the constraint of C was super nice to have.
Mm-hmm.
And I would look at, first of all, I look, of course, at what was coming to C in C23 and so on. I was also looking at all proposals for C. I was looking at, of course, the GC extensions. So a lot of things in C3 is just like these GCC extensions, everyone loves them, but not everyone dares to use them because they need to compile on different compilers, so they don't use them. So those are also like standardized into C3. So a lot of features are like, I didn't want to add features that weren't proven. So adding those felt like, yeah, for example, doing something like a designated initializer with a range, right? So that's not supported in vanilla C, but has some GCC and Clang. So doing things and like having people being able to rely on that was something I wanted to do. And I've also looked at like a lot of different other languages. I've always looked at the other C replacements, and the previous ones. I mean, there are a lot of old kind of C replacement attempts. The older ones are mostly like, here we have C, and let's add a bit of objective-oriented stuff on top of that, but with not C++, but in almost C++. I've looked at those as well. I've looked at, for the macro system, I did a lot of reading on alternative macro implementations. So the semantic macro system is actually like mostly inspired by one macro system that someone did for C, which is called Aztec. And they had like, yes, it was just mostly to be able to refactor accurately the C++ CVP, the preprocessor code. But that one has had some nice ideas. Now that one didn't have any recursion or something like that, so it just but it just kind of formalized the different scenarios of what the C macro system was doing. So I looked at that and obviously looked at all different ways of doing syntax variations. And I tried doing a lot of things that I looked at SIG a lot in the beginning, actually. I tried their stuff. I threw it away. So there are long examples, like investigations of why I threw those away also. So I have this, like some things where you kind of think of as trivial turned out to be like, oh God, I have to think about this a lot in order to make this work. So something simple as, let's say you have A, and A is an integer, or a 64-bit integer, like like that. So you have an int A, as long A equals B plus C, right? So you have that, but B and C, they are integers or shorts, maybe. Like, so it turns out that that kind of the conversion, the widening conversion, people are generally saying like, yeah, narrowing conversion is bad, so C has is bad, but widening conversions are fine, but they aren't. So it turns out that if you think about having something like that, if you have a widening conversion that can happen in two different places, you can have like you widen B, you widen C, and then add them together and assign that to A, or you add them together and get whatever overflow that is in that, like on a short, and then you convert, widen that one. And there are quite a few bugs that you can get that are really invisible with that kind of code. So it's I hadn't thought about that, and C kind of avoids the problem because it's most of the time, because most of the time we would just promote both sides to int, and then it's usually wide enough to not cause an issue. So it's just a problem when like it's assigned to a 64-bit int and the pieces are 32-bit and it's promoted to 32-bit. So you get that like a long equals int plus int. And that was like a eye opener for me, just discovering that in like just trying to fit some feature. That was because I had started with Zig and tried to, but I found some things I didn't. I wanted to do it differently with widening, and then boom, it kind of I discovered these things kind of hidden. So you run into these things that you can really dig into that are easily assumed to be solved. So then you have to really look at different alternatives but going back to the thing like how I looked for inspiration, it's just different languages basically. I looked at look at the old ones, the old school ones like Modular 2 and Nada and stuff like that. See what they did, and sometimes like this thing with Algon 68, how it had all the features that we're now just rediscovering, and you can really do that too with older languages. The whole, if you do something which is more procedural, then you can absolutely look at all like Pascal and Modular and all of that, because they were doing that before this OO thing got into focus. Because once you go, oh, there are so many other considerations. So a lot of these small things kind of get unimportant. If you have a later language, maybe you have infinitely ranged integers in the first place or something like that. They get less interesting because they're farther away from something like C.
Mhm.
So
Yeah, absolutely. So I wonder, for this next part, I was thinking about just screen sharing and hopping into the C3 language and um, on the website and having that inform some of our discussion. How's that sound?
yeah, I can do that.
because it's not often I get the designer with me, so I always take advantage here. So let me go ahead and just share the screen here, and we should see something coming up here. Right, so I've got the website here. Let me scroll to the top. And I think it's one of the next questions I want to talk about. But let's just go ahead and go to the tagline here. Simple, fast, safe, compiled for developing maintainable software. Is that sort of true? Has that changed as the language keeps evolving? Are those the goals still accurate, I guess, of C3?
I think that's like the tagline. It's it's a tagline. But I mean, it's fairly true. I think of it more like if I would have a tagline that is more accurate, that I would think about this like it's a C like for people who like C, right?
Yeah.
So, but you have to explain what your language can do. So yes, it is safety here is, C is kind of safe if you put on all the like, sanitizer and stuff like that. And Zig is like, we are really safe because we have more stuff built in. And yeah, C3 has that. But one thing that they don't have, which is kind of a hidden feature, which people don't understand, are the contracts. So I really like that I have contracts in the language, and they have been really useful. And people are like, what have you done when you look at on the for like at the contracts? But that is what is going to be I think, very helpful. So one of the things that I always do when I program myself is like trying to put obvious asserts everywhere, just to make sure that everything, is the way that I expect it to be. And asserts is like the poor man's contracts, really. And the classic thing with a lot of code that you write is that you take care of this the erroneous input. So you say, okay, it's something is wrong. You can like, oh, it's not let's search. Let's say you search something for something, and then you write code like, oh, if your search is not a string, it's supposed to be a string. Oh, that's an error. If it's not there, oh, that's an error. So they kind of get conflated with like this is bad, this is incorrect in data, and this is like something bad, not just something just failed that can fail. And there was on the Midori blog, Joe Duff, I think, wrote a long article on exceptions for Midori. And he went through this, like how it's a bad idea to conflate these things, like these exceptional things, and these that are just different things that happened. And I think a lot of people actually in the language community found that very useful and very correct. And so what I took that to the limit is that I have the contracts. So the contracts will fail at the runtime if you have the safety on. And if it doesn't, then yeah, it's you can choose to have this, you can write code that actually shakes that all the time. But mostly that will run unless if you have safety on, you will always check these things. And the more you do these checks, the more data, the more you will be sure that the data is correct in out, right? So the earlier you can track the incorrect data or the incorrect assumptions, if you have like the insurers the contract, right? So it says that this data should be in this range. And then once you have that, you can start doing static analysis on this. So right now, it's just doing that on macros, but at least on macros, you already know the in data. So if I can constant fold this, because C3 is doing constant folding as a way to do compile time evaluation and some compile time execution. So for example, if you put a null into something that is not shouldn't take a null, then it's an error, compile time error. And also use this to expand this to do everything which is like kind of untyped because they're macros. Then you can do the same thing. So you can like, okay, this is the wrong type. At compile time, you can check the type for you. So unlike C++, where you kind of you go far down and somewhere deep down it's used, and then you check the type and it's bad, right? Here we have the contracts that are compiled into the caller of that function. So, and it can test, okay, you sent the wrong type, so the type doesn't match the constraints for calling this macro. So then it's just an error, just as if you had written the code, like the wrong arguments to a function. And the same thing goes for the generic modules. So for the generic modules, you can also say, like add certain constraints on the types or constants you pass to that. So that gives you both, like it just takes both the compile type validation, and then you can do static analysis, and you can like decide how much, like the compiler could theoretically do as much as it wants. But the idea is to kind of for the compilers, the language specification is up to a compiler to just do as little as it wants or as much as it wants. And this is something I think is good about the Hair language. So the Hair guys, they decided to upfront, we're going to have a specification. You're going to be able to, implement this language from a specification. And that's like something I totally agree with. And it's good to think about, like, how will someone else be able to implement this language? Because otherwise you make the language so darn complicated, so no one else can implement it. That happens to C++, but I also see that in new languages where you kind of like add things, and where is the specification becomes like there's this reference compiler, and that's the only thing people like people will only be able to use that compiler. And that I think is bad for kind of a future to have just one compiler that you can use.
I think
Yeah.
I've noticed a lot on your blog, which I'll link in the description, and folks should read, especially in that last point. Well, I'll make 2 points, but on this last point, if no one else can implement your compiler or make an LLVM version or GCC or something, you are right. I think the language is probably going to die after some time. If no one can implement something beyond the reference compiler. And I think that's something maybe from a language design standpoint folks don't think about too much. And I think you have a lot of interesting thoughts again on your blogs about why languages will fail or succeed that are worth folks thinking about and discussing. And the second point I'll just make briefly is because you mentioned the Hair language, which I think much of our audience maybe hasn't heard of, or maybe this audience has since they're listening in. But you really have done your research on different languages. Because, again, these are not, or at least that language in particular is not one known by, let's say, millions of people. So that's very cool. So let me just scroll down here again, just to give a few of the features here. And I think a lot of folks are going to understand, the importance of C ABI capability, this being C3, but also just from using libraries for so on. But some other big developments, I think, beyond C are things like the module system and semantic macros, which we've talked about. And you've talked about semantic macros for both to sort of improve on the C preprocessor, the compile time execution, as you mentioned, and also contracts on that, which is very powerful. So between these two features, were these sort of must-have for you when developing C3 to have a module system to simplify things and a good or better preprocessor?
Yeah, it was like these were the module system was already there, or one module system was there in C2 already. I then changed the module system, so there are some novelties, and novelties are actually bad because then people don't know how it works. But there are some novelties in that, in the sense, but that's more in usage. So this modules were already there in C2, right? But for macros, that was like one of the unsolved problems with C2. So that was one. When I looked at the C2 compiler, I felt like there is not room to do this because you would have to need to compile time evaluate everything that is foldable. So from the beginning, the C3 compiler semantic analyzer is kind of just constant folding everything. And for most part, that's just like 1 times 2, or something like folding that to 2. But then there is also things like you fold entire macro if the macro doesn't contain anything but like in the end after folding everything only contains a return statement, then that is a constant and just falls into a constant. And then you can build like the entire system is just like, oh yes, let's just fold these things. And then you can get some compile time execution and so on. But I also wanted to make this not it can't be too big. And if you do too much, like the people, I think that when people think of macro system, they'll think like, oh yeah, the bigger the better, right? That can you do amazing things with this, then it has to be better than you can't do a lot of things with it. But I feel that the macro system the hardest thing is to stop. Say no, I can't do anymore. And what I wanted to do is like make the macros as readable as functions. So you should load something, it looks like a function, but you can, maybe the in parameters are variable because they can have different types, and you can have like the compile time if statement will do different things every time, blah, blah, blah. So they are like functions, and should be readable as well. So that was my idea to kind of stop there. And recently I implemented something called expand, just for an experiment. And I was like, no, I should really not have that. And that would take like any text and just expand that into code. So you could write whatever you wanted there, because you could, at compile time, you could construct, I can construct strings and introspect stuff. So you could, let's do that and you can create any code. So I quickly removed that because it's not, you can't encourage things that you don't want people to do.
Mm-hmm.
If you do that, people, like if you put something there, people will think, yeah, that's a good idea. Let's do that because it's obviously there. That's a feature. It's easy to do that. Let's do that. So there is like this exec thing I have. So in the code, you can actually call out to any script, including C3 files that are then run and interpreted as scripts and get code back. So you can do whatever you want, but that's more of a code gen. You write that is a separate thing that actually generates text, and that's like you can monitor that. And can even if you have an IDE, it can probably like just intercept it, and you can see what the code is, and it's nothing magical with it. With doing that, you don't have to think about like what does this code generate, what kind of string does just you have that string. So that's like the out. You can go there, and you can also like in the project builder, like the project build thing, it can call out to scripts automatically. So you have that. But that's like if you want to go beyond this kind of level, let's do that. Don't do too much code gen. So one of the things which is like not there is there are no type generation. There's no type generation. You have this type generation through the generic modules, but those are like already types. So the only thing you change is like this is the type. Maybe something changed, the types inside changed, but it's already well defined. But no types, because once you have types, also during compile time, things like, oh, now there's a type, and now there's if you're going to inspect some type at compile time, maybe it exists or not exists, or everything gets more complicated. So keeping it simple
Yeah, knowing when to stop, I think,
Yeah, this it's hard.
and especially, I'm sure you've got pressures from folks who are trying C3 and saying, yeah, why don't we have this feature X, Y, and Z because we like using this other language. That's got to be difficult to tell where that sort of line is being formed, I guess, of this is going to be a feature or no, it's not going to be.
Yeah.
Um, but speaking of a few other features here, when I initially looked at C3, some things that I love and I think are hard to stop using once you get used to them, but slices. And in particular, things like having talk about the safety of the language, where a slice is the pointer plus the length, again, which is like a string view for my C++ folks or spans. Um, these are just very nice. Was this an obvious feature when you were developing C3, or was this something C2 already had that you put in, or
No,
um,
strangely enough, C2 didn't have that, but it was an obvious thing.
mm,
I mean, I think everything from probably, uh, I mean, views, that's something we've used for a long time. I think JI had that. They,
mm-hmm,
I think that John talked about this explicitly, and then everyone else was doing it anyway. It's like Sigurd and Odin and stuff like that. So we had that was like already around the and other languages were all also using it more and more. So yes, it was everywhere. So it was obvious. But I was actually not looking for the slicing as much as for each.
mm,
Because one thing I noticed way back, so like way back when we got, I think, Java 1.4, and I was doing a lot of Java. So how many of these if for statements that just disappeared because you got for each.
mm,
And every for each that you have is basically you don't risk indexing out of bounds
mm,
because you already have the bounds done for you. So that was what yeah, and I think also programmed a lot of PHP, like I talked about that backend. And so there was so it very rarely happened that I actually used a for loop because almost always you just would just iterate over something for an array. So I think that is like the number one thing that you don't have to you have this for each. You can go these for eaches can go back and forth, and you have the index, so you can go for like changing that, like indexing something else if you do something in parallel. So having that, and also I didn't want to add operator overloading, but there is operator overloading
mm,
for being able to do these for eaches. So you can do that on the dynamic lists and stuff like that. So just not having to do that would remove a whole group of bugs from that manual iteration where you can just mistype something so easily. And
mm,
also the optimization that you always want to do, where if you have something that has a length that has to be calculated, you have to put that outside the loop. Yeah, get the size and then like input in the variable and then have it compared to that already calculated one. And that's an optimization I think I've done like a gazillion times because you just want that you don't want to, you're not sure that the compiler is going to do that for you. Maybe they doesn't understand it. But if you have for each, it will do it automatically every time. So it's just uh, it's just such a security win, actually. That's
mm,
probably the one thing C should, I mean, C could add this. Really,
mm,
C could add this to a C 23 or C 26 or whatever. There's nothing difficult with it. I mean, there are complex types. Complex types is they are two. They are basically like a struct, and they have that natively. The atomics are also have like some payload. I remember some of them at least. So I mean, but just look at complex numbers in C. So you already have those kind of two two pointer sized structs that you could pass easily. So yeah.
Yeah, so I love this feature. I mean, again, as you said, it fits right in with the safety story, making your code easier to read and write, which is excellent here. Looking at some of these other features, I think I understand them. So we'll dive into some of the examples again, just to see some of these things that we've been talking about. But there is one more thing on this page that I wanted to highlight and maybe hear about was this project right here. So someone, or maybe yourself, I don't know actually the story. How did Vulkan Quake in C3 arise? Do you know anything about that? Because
Okay,
that's a
so
pretty cool
that's
project.
actually that yeah that's not nothing. That's a
Okay.
small thing. So what I did was basically, and I tried to make clear this is not impressive at all. It's just I wanted to do. I basically took the this the make file, and then you could just as part because if you run the C compiler, you output all these .o files, right? So
Mhm.
the C3 also outputs .o files. So just output a .o file, just conform to the same exact same header
Mhm.
as the old one did, and it just goes through my code, and because it's just C code and just works like that in the workflow. And I don't want to I wanted to show that you can just write normal C3 code and it's intended to work like this. It's like it's intended to just fit in if you want to. You shouldn't write your libraries. You shouldn't port everything to write it in C3. C3 doesn't bring uh, that kind of productivity gain in that. It's not nothing extra. But when you write your program, it hopefully gives you more simpler ways of expressing things that take more time in C. And I think the biggest problem with C is really that, or why people have a difficult time using C, is that there are so few cross-platform libraries that express fairly, still fairly low-level simple things like a dynamic string,
Mm.
a dynamic list, hash map, all these things that everyone takes for granted. So in C, you keep on building them over and over again because everyone is doing that. And when teaching C, well, teaching C, usually all books and stuff like, well, here is the C library because why should you use any other library? Because you have to learn how to use these hard things. But then people, oh, okay, I see code written in C where every single line where they have to do something with a string, they create their buffer on the stack and check their, the length that have to do that. Maybe if they are careful, they do some dynamic allocation in case it overflows. And for every time that you're using a string, I mean, it's like so simple things. And because people aren't using these libraries that actually exist for C. So peop when people think about language, they usually think about like the language plus the standard library. This is like a thing that Ginger Bell keeps like talking about. But it's completely true. I mean, they always think about the standard library as part of the language.
Mhm.
And that's why C becomes such a difficult thing to do because
Mhm.
there's almost no standard library.
Mhm.
Uh, and so then we come back to C3. C3 is not, it's not that you are making development different from C. You're not supposed to get any benefit for your language or for your library just because you write it in C3. It's more of you can write some things clearer and safer and have more checks than in C. But you could have that if C that's basically, you could have that in C2 if you could remove some things and evolve. So it's nothing new. And the one of the things that other C competitors doesn't seem to do, that C3 does,
Hmm.
is that C3 is actually compatible with C3 for dynamic libraries.
Hmm.
So if you write a dynamic library in C3 and another dynamic library or your application in C3, you can use C3 features.
Hmm.
So if you do something like Zig, Zig can't talk Zig. It has to
Hmm.
talk like C layer, C types, the compatibility types, the compatibility functions. They can't use errors. They can't use anything with the other SIG code, the SIG library, because they have like this interface is all C, but
Hmm.
their C, but their language is not really C ABI compatible.
Hmm.
So it's not the same thing.
Hmm.
Whereas for C3, all the C3 things have a counterpart in C. So, okay,
Hmm.
there's a slice, and slice right now, I hope to change that, but right now it's just a struct, right? But I would like to have so that actually places things for from viewing from C, we should place it like two elements, like a length and a pointer, because that's more comfortable from a C kind of perspective. You probably don't have a struct. Um, and you have an error from even an error code from C, like these special errors or faults in C3, or error returns, these optional returns, those are representable in C as well. So you can do that. Those you can do all these things and just talk back and into C3 or out of C3. So it's like very much bidirectional, and it's not like I want. It's not like, okay, I use some C libraries here, but I can't build a C3 library that interfaces with C. But for here, for this, like you really can. You know, it's ideally I should have a C generator backend so people could like just use C3 and create C3 code that and just use C3 and then have C with their project. But it's like this: you can pick and choose. Like someone would have like, okay, there's C and C++, right, in code base. That's completely acceptable. Like some people parts are C++, some are C, and they work together. And I want like same idea here. So that's just what I improved, what I've shown. So I haven't ported the whole thing. Um, um, I could probably be done now, but it seems like a, a big project when I have so much other things to do. Uh,
Yeah.
so it's not impressive, but it does show the calling in and out and also
Hmm.
integrating with the build. So basically, um, this whole thing that it actually outputs an out O file, and it actually does this. It just does as C does. Every file, every compilation unit becomes a .o file, and then you link them together. That's how C3 does it as well. That's why it can, just fit it into a C compilation path, right? Or you can be compile C as a part of the C3 compilation as well. So
Yeah. And I
that
think
kind of
that's still a very impressive, you know, part of your tool chain that this is working. I was quite impressed, and it, shows that the ecosystem's working. And maybe now's the appropriate time to challenge someone in the community to do the full port. I'm sure someone will at some point. It'll be interesting to see, the safety gains and so on. So I think that was just really cool. So, but with that said, I guess I could show very briefly, right? The hello world is a simple. So for folks who do want to download C3, it was very easy to compile um, and just get an executable working here. But I actually just want to look through some of the examples, and we'll kind of start wrapping up here. But there were many features that I loved and made me, and I hope other folks will try out C3 more. Vectors was another one. that came in here that again and again it's not exactly the C++ vector, but this is more of a uh, type,
SIMD,
I guess.
yeah, SIMD,
SIMD.
SIMD,
Yeah.
yeah, SIMD.
Yeah. So when did this come into play? Was this just again another necessary thing that you said if we put this in the language and make it easy, this will be awesome? Or what were your sort of thoughts here?
Well, you have to integrate the vectors eventually. I mean, it's in C. It's
Mm-hmm.
basically in C. It's not officially in C, but it's in C. So you want to make it a nice experience. And I mean, I think it just follows on once you have a way to declare the types this is Clang is supporting this kind of vectors that are arbitrary lengths, right? And once you just do that, it's natural to see like, okay, let's do addition and multiplication and do that on the vectors. And things just follow from that. And what I did though was, I don't know how much you've gotten into this, but you can have methods, type methods. You can have methods on every type. So you
Mm-hmm.
can have methods on your int type or whatever. But they're not thought of methods in the kind of way that you're supposed to like do that and then things will happen. But
Mm-hmm.
maybe this is just a way to kind of expand on what operations you can do with the type that you otherwise would have functions with doing. So you like on screen here, you have like the sum, which down could have just as well been a function. Of course, you could have like
Mm-hmm.
a sum of the vector, but now you can do it like stack them a bit if you have dot. So it's dot invocations. So for the things for plus and minus and division and all those are all um, normal CMD vector things, so per element. And then you have these extra features on CMD that you typically have, like sum, which would sum all the elements, and yeah, and then we have product and so on.
Mm-hmm.
So those are, then I could add those as dot functions, and I have a way to like kind of generically do that with macro methods. So those are some features we didn't look at, but they are kind of happen to be very powerful to do that. So I have all these things that are defined in the standard library and just do that. So hopefully, I think people can, like to work with SIMD. So the SIMD vectors are implicitly convertible from the corresponding normal arrays.
Mm-hmm.
So which means that you can often with C you want to typically put this as arrays in structs, and that's why you pass really arrays by value. So you put that in a struct or something, and then when you get that piece of data, you grab the CMD and then do all the operations.
Mm-hmm.
So I did a lot of this in Advent of Code. I did for 2022 and in 2023, because then you typically get something and you maybe two coordinates, and then you have to move that or something. And it's very convenient just do that in a single, multiplication, and then you know, just working with vectors as normal physical vectors, stuff like that is I have these functions. It was very, very nice. Like just much less code, basically.
Mm-hmm.
So I think they turned out good.
Yeah, it's very clean. I mean, it's giving me, um, at least from a graphics programmer perspective, most of the things that I need by default to get started. I also love that you had the swizzling here again for graphics and game programmers, or just other folks doing other types of interesting, masking operations and things. It's all here, which I loved, and these can be big quality of life features in a language. Um, let's see what else was here.
I have to credit where credit's due. I think these are originally the one who really did that in C-like was Ginger Bill with Odin.
Mm-hmm.
So Odin has general array um, programming with all these on all arrays. Whereas here in C3, it's just on the vectors, which is more fitting with C, which how C also works when they have vectors. But and he also added Swizzling and all of that. So I think Odin is a very well designed language, which I so would like to uh, say. But I've looked at Odin a lot, so it's
Hmm.
very. I really want to give credit where credit is due here for that.
Yeah, I've noticed. Yeah, between those, and I've spoken with Ginger Bill. But both have this swizzling, which again as a graphics programmer, I love this. So I mean, we could spend equally hours and hours going through, but I just want to highlight for folks interested in C3. I mean, you've got a lot of the stuff that you'd expect from modern language, from air handling, optionals. Um, Let me see what else is here. The macros, as we mentioned, with the semantic macros. That again is really interesting. Compile time evaluation, which is just another one of these must-have features. I've seen it in JAI, D language, C++ is finally starting to get more of this. Um, any interfaces. So I mean, there's a lot of stuff here that um, is certainly possible and part of the C language, but other things, reflection. I mean, maybe we should let you talk a little bit about this, or if you wanted to jump in on those other features. These are just such huge things that, when used appropriately, can really make a programmer's life easier. So, I'm really excited to hear what the reflection story is going to be, and that you're thinking about this for iterations of the language. Yeah, do you want to comment at all on reflection and or any of these other topics I mentioned?
I think well, I think the reflection is the one I would like to talk about is actually the error handling because that
Oh,
was
perfect.
is a bit different. So I like to say that I want to avoid inventing things. I would like
Mm-hmm.
to do things that are already established to be working. But I felt when I worked on error handling, it was hard to find something that really satisfied me. But it's too easy for code to kind of go into exception style handling.
Mm-hmm.
And when I say exception, what I think is the worst is that you immediately need to handle the error. And that's not really, if you have like, we already talked about the contracts. So the contracts are handling the exceptional, really exceptional bad things.
Mm-hmm.
And so these are just error messages like this is not found or something like that. And you don't want to model that with really an exception. And you might want to do different things depending on what the situation is and also defer that. So the nice thing I think about Go is that because you get the error and the value, maybe value, you can decide in specific cases when it's not like you need to just rethrow it upwards. You can do some things and maybe do something in concert with something else. And I tried briefly like the SIG-like way. First, the Herbceptions was the Sutter's version of C++ exceptions that would throw a value. So that kind of fits. So it has some value that is returning. But I turns out the syntax and the thing felt too much like just exceptions. And then I looked at Zig, and but also Zig has also this kind of it wants to immediately handle everything. So you have the try, and either you handle it or you throw it immediately, and that's not always what you want to do. So back in when Swift was first released in back in like in beta, they were like, "Oh, we're gonna use optionals for everything, for errors and everything." And people quickly discovered that that's not enough because you usually want to know why the heck was that thing missing. But other than that, it was kind of convenient because you could do chaining and stuff like that. So you can chain. And this was kind of borrowed from Objective-C, which had null messaging. So if you message to null, a null object in Objective-C, you get null. So you get like a key or nil, which is what's the actual name in Objective-C. But you also get nil. So you could just do things safely because you didn't care. So you just message that one. Maybe you called something to get some value, and then you message something, and then you go look at the return value. And the return value might be nil if it failed, but you also got the nil if you didn't have that. And so it called something that was nil. So these kind of errors here just got conflated. So if this failed, this was never called, but they both returned a nil value. So they kind of worked together and that kind of worked, right? It worked surprisingly well. So the idea was can I find something that is like between a result, a result and an optional and a go style and convenient like exceptions. So that's what I tried to do. And I come up with an idea that it's not easy to explain right now, but for people who are interested, can take a look at this. I've been working on a longer thing, but basically it's like a result, but you can handle it like an error, an optional in Swift. And it kind of just it gives some nice example. If you can maybe scroll down where you have this simple while loop where you have like a while try, and you can just do if try if you go down.
If try here.
Yeah, further down. You have some implicit and wrapping. So it's kind of like some languages deal with null values. So, but here I use that for the errors. And the errors it's like a null, but it has a reason why it's null. Something like that. You can think about it like this. Or an optional empty, but it has a reason, but doesn't have a payload. And it has you can do the chaining because of that. Because there's just this kind of hidden error so you can do chaining. So you can call if you have an optional return, you can have it as an argument. Oh, sorry. Just scroll up a bit here. Maybe like what you typically get with the while loops there. I don't know if they have that one in there.
Let's see here.
Some common techniques there. Think further up. So you get like this. No. Oh, never mind. It's probably in the example somewhere. I know it's there somewhere.
I'll find it and link it in.
But it's actually this particular feature, which just seems like this is a small thing on top of C, just managed to give some real new patterns in handling errors. So that's, I think, if you would ask me about like what people would notice as a change when they program compared to C, it would be like using these. Because they still can get them, kind of work with them, kind of like Go returns, but you don't have but you have some inconveniences, really.
Yeah, it's a really powerful feature. I mean, otherwise in C you get, you have assertions, and I guess you could return error codes or exit, or I guess you could implement your own exceptions in some form, but having these, and like you said, being able to sort of have like an optional, for instance, or this idea of, I mean, the try, which I actually haven't looked super carefully at, but this itself could be very powerful pattern, like you said. And what I've also found, when looking at languages, is if you make these features easy to try and you give these tools available to developers, they actually will at least try to handle the errors versus, not having these features. So in that way, that can be a huge improvement to make these things easy to use in the language. So that's very powerful. And I see also, I mean, you're showing an example here, chaining these together. Again, very powerful pattern that, I mean, this would be something that, if you're handling this with exceptions, I mean, I guess you could sort of have a bunch of exceptions that you're handling or something, but it gets quickly very, very messy. So I don't know an easy way to do that pattern in other languages.
I think what I like is I mean, you have something like this already a little in Go where you can get some defaults,
Hmm.
and you have for like Kotlin and stuff where you have the and C sharp where you have, we can have a question mark to get like if you have null and you get something else.
Hmm.
So these techniques kind of already exist,
Hmm.
but I used them and added basically this is the optional, and it's not an optional type as such. It's more like a binding because you have only have like the return type can be an optional, or a variable can hold an optional result, but there's no optional parameter. So this kind of there's some special things to be able to make this work, and it's hard to explain, but it's easier to use actually in practice once you start working with it. But the it is already used really, and it's for this flow typing like Kotlin does with null. It's a very nice thing to simplifies really if you actually happen to use null for things. But here it's no null, it's just the optional, so you can't really do anything wrong. It's just yeah, you have to unwrap it. So then it becomes more like an optional in something like Rust or something, or some functional language. So I kind of combined these, so you can try them out when you want to. Once you wrap your head around it, this is kind of you can see it that it compresses some C code quite nicely.
Yeah, excellent. Well, I'll go ahead and point folks to the C3 handbook, the C3 website for finding more information. And I know you have, folks pinging you on Discord and so on, but I'll encourage them to check out the website first to learn a little bit more, myself included. And what I want to actually do now is kind of start wrapping us up with some just rapid fire questions. So first thing that comes to your mind as we kind of close the discussion.
Oh,
Um, do you have a programming a book, an article, or a video, something that you'd recommend all programmers watch? Anything that comes to mind?
I don't think so. It's over the years I've read so much different things. Like what really touches you, it really depends on where you are in your career, what you've learned so far. So,
Any general advice or words of wisdoms to young programmers just getting started?
well, I've talked about that you have to stay away from doing too much OO, right? Object oriented. But yeah, try to learn everything.
Mm-hmm.
Just learn. Don't be afraid of, boring stuff. Learn how to be like everything, and you'll get better at it. Because the worst thing is like if you do something and fix bugs or whatever, and it's like this is horrible, and you tell yourself it's horrible, it's going to be even more horrible, and you're not going to be better at it. So it's just find the fun thing about it, and if it's not, you can. When you're interested, you're going to get better, really.
Next, so you've had a career also doing game development. I wonder if you have a favorite game or title that has really captured your attention at some point in your lifetime.
Oh, I think that's hard because I'm old now, so you have like these titles from the beginning that you would like play, and they would be like so amazing at the time. And then you have like modern games that are graphically um, more different, like much deeper. I guess I don't have as much time to play games anymore. That's the sad thing. The sad thing of it. Um, but I still kind of appreciate the really old games though, the arcade games, because of the kind of the grinding thing. It's like it's impossible to complete. You just have to grind it. So I'm fine with playing something like Returnal, which is like just grinding,
Mhm.
because this kind of goes back to these old games, really. right? Um, so I could play, actually, I play a lot of, got these old arcade games like this Galaxia and all these. I mean, this is really fun to kind of, even though you suck at, like in the beginning, it's like, it's one of those, those old games kind of, you get better and get better and better. You can't play them for long because it's like, it gets boring, but it's fun to kind of play them occasionally, more so than kind of games today, which are more, they are easy because it's for everyone, right? But otherwise, other than Returnal, probably I play the Horizon series a lot. Like that's the ones, and Zelda play a lot. Those kind of open world, but doesn't say anything. I love to play a lot of like fighting games like Tekken, but I'm kind of I like the old Tekken versions better. So I
Excellent titles, excellent titles. Yeah. Well, Christoffer, it's been an absolute pleasure, and you've given us more than a fair amount of time today. So just want to thank you again. I'm going to link to your website, and I'm going to give you the final word, whatever you want to leave folks who are listening with.
I don't know. I have a final word. Just go out and have fun programming, everyone.
All right. Thank you so much. And we'll look forward to hopefully talking to you again soon and seeing what happens with C3.
Yep. Thanks.